A very good day for daughter. We are group 7. First is SREP. This study is titled The Applications for Electrical and Electronic. There are three objectives for this study. Firstly, differentiate between electrical and electronic devices. Second, choose a few parts of electronic equipment as example and explain how they work with DC and AC supplies. Thirdly, identify the factors that contribute to the burning of an compressor circuit at home and give solutions to prevent it from happening. Moreover, this study will discuss the difference between electrical and electronic devices and select a few electronic devices that operate with DC and AC power supply. An electrical device is to transfer into other form for energy, while an electronic device focuses on smaller electronic circuits. A smartphone is one example that uses both AC and DC power supplies. Besides, this study also will supply an equation solution to avoid a technical problem. The technical problem that may cause the burning are short circuits and overloading. The solution to avoid technical problem is to replace or repair damaged electronics costs, unplug all appliances when not in use to decrease protection risk, and electrical devices and outlets should keep away from water to prevent shock. As a result, in this project, we must determine the loss ratios for a burning source to prevent it from burning again and supply some solution.
I'm going to present about the introduction. Electrical and electronic practices refer to the various methods and techniques used to design, construct, operate, and maintain electrical and electronic systems and devices. In terms of safety, it involves using proper safety practices and equipment when working with electrical systems. It is important for us to properly understand the notion of electrical and electronic practices as it consists of many applications in our daily life. It includes household items such as microwave and washing machines. There are no exact statistics for the number of electrical and electronic injuries or deaths in Malaysia. The mishaps in the homes were caused mainly by unlawful wiring and unauthorized and low-quality electrical equipment. Electrical is concerned with the movement of electrical power or charge, whereas electronics is concerned with the flow of electrons. Electrical and electronic engineers work in various industry and fields including telecommunications, power generation and distribution, transportation, manufacturing and healthcare.
Differentiate between electrical devices and electronic devices. For the definition, the electrical devices is to transform into other forms of energy, such as heat, light, or sound using electrical devices. The electronic devices is to focus on smaller electronic circuits. It regulates the flow of electrons. For the material, electrical devices is the performance of any electrical device is entirely dependent on the quality of the materials used to create it. To create successful and efficient electronic devices, we must be aware of the factors influencing the quality of engineering materials. The materials are the conductors, semiconductors, insulators, magnetic materials. For electronic devices, all things around us are mostly made of electronic materials. The materials are stone, bronze, iron age, synthetic, and smart material ages. For operating principles, for electrical, Ohm's law, a rule that states resistance and voltage are inversely correlated with electric current. Meanwhile, for the electronic, we use the Kirchhoff's law, or known as KCL. All current entering and leaving a node must add up to zero algebraically. Current, an electrical current created by the directed movement of electrically charged particles in an organized manner. Voltage, the force applied by the power source of an electrical circuit to force charged electrons current through a conducting loop. Power consumption is to show how long portable devices like laptop, computers, and cell phones can operate on their batteries. Lastly, manipulation, the data is not changed by electrical devices, whereas the data is changed by electronic equipment. Response time, the amount of time it takes for a circuit or measuring device to change its state by a specific percentage of its overall reaction to a change in input signal. Required space, all electrical and electronic devices must have at least 30 inches of clearance on all sides, but never less than the width of the equipment. Safety electrical, avoid working with conductors carrying 50 volts or higher that are exposed. Safety electronic is to unplug the power source. Uses, electrical energy is to transform into other forms of energy, such as heat, light, or sound, using electrical devices. To carry out a task, electronic devices is to regulate a form of electrons. Examples of electrical devices. There are two types of electrical devices, which are transformer and mobile devices. Transformer, it transfers energy from one electric circuit to another circuit, the electromagnetic induction concept. It is intended to change the AC voltage between the circuits while keeping the current's frequency constant. For mobile devices, the electrical energy is transformed back into sound waves and sent over lines to the phone, where the user may hear it. Examples of electronic devices. Pager, a tiny radio receiving device for communications that connects to the paging network. Paging network transmitters transmit signals over a certain frequency. For the air purifier, it interacts with the positively charged filter or collected plate because it is negatively charged with negative ion.
DC power supply. It is a device that supplies direct current DC electricity to a load or device. It converts alternating current AC electricity from a wall outlet or other source into DC electricity, which is typically used to power electronic devices and appliances. AC power supply. It is an electronic device that takes AC from a wall outlet or other source and converts it to a predetermined voltage and frequency. Electrical current from a wall outlet is often characterized by alternating flows of charge. One of the examples of the electronic devices that operate with a DC power supply and an AC power supply is smartphone. When plugging the smartphone into a charger, the charger converts AC power from a wall outlet into DC power and delivers it to the phone's battery. The battery stores the DC power and uses it to power the phone's electronic when the phone is not plugged in. In addition, motor is also an example that operated with a DC power supply and an AC power supply. DC power supplies can be used to power motor by providing a steady DC voltage and current to the motor's windings. In some cases, a DC power supply may be used to power a motor through an inverter, which converts the DC power into AC power. This is often done to control the speed and torque of the motor, as the frequency and voltage of the AC power can be easily varied to achieve these control objectives. Reasons that may cause the burning is short circuit. A short circuit is an unusual incident in an electrical circuit in which the electrical current travels via an unexpected shorter route rather than the circuit. The technical issues related to short circuit that may cause the burning of an electrical circuit include electrical circuit protection. A short circuit can cause circuit protection devices such as fuses and circuit breakers to trip or fail, which can disrupt the operation of the circuit. In addition, voltage and current. A short circuit can cause the voltage and amount of current to flow in an electrical circuit to increase, which can cause the circuit to overheat and potentially burn. Furthermore, resistance. A short circuit can reduce the resistance of an electrical circuit, which can cause the circuit to overheat and potentially burn. Moreover, AC versus DC. A short circuit can cause the type of current flowing through an electrical circuit to charge. For example, a short circuit in an AC circuit can cause the current to flow in only one direction like a DC current. This can cause the circuit to behave differently than expected and potentially cause problems. Next, electrical power. A short circuit occurs when there is a direct connection between the positive and negative sides of an electrical circuit. It can cause a large amount of current to flow through the electrical circuit, which can increase the power being drawn and potentially cause the circuit to overheat and potentially burn. The next reason that may cause the burning is overloading. It is a common cause of electrical circuit failure and can result in the burning of the circuit. When too much electrical current flows through a circuit, it can cause the circuit to overheat and potentially burn. It can be caused by using too many devices on a circuit or using devices that draw too much current. The technical issue related to overloading that may cause the burning of an electrical circuit include electrical circuit design and sizing. It is important to design and size an electrical circuit properly to ensure that it can handle the power requirements of the devices being used. If the circuit is not properly sized, it can cause the circuit to overheat and potentially burn. Next, voltage and current. The voltage and current flowing through an electrical circuit can affect the power being drawn. If the voltage or current is too high, it can cause the circuit to overheat and potentially burn. Furthermore, resistance. The resistance of an electrical circuit can affect its ability to handle the current. If the resistance is too low, it can cause the circuit to overheat and potentially burn. This can be caused by using a wire that is too small for the current being drawn or by a failure in an electrical component such as a resistor or a switch. Next, AC versus DC. High electrical power due to overloading can cause damage to electrical components such as motors and transformers and can also cause overheating and fires. High electrical power can also cause voltage spikes, which can damage sensitive electronic equipment. Moreover, electrical power. The power being drawn by an electrical circuit shows the rate at which energy is being used. If the power being drawn is too high for the circuit to handle, it can cause the circuit to overload and potentially burn. This can be caused by using a device that requires too much power or by a failure in an electrical component such as a transformer or a motor.
Solution to avoid technical problem. First, we have a key electrical device from water to prevent shock. Electrical power and water may not interact. Electrical equipment should be kept dry and away from water to reduce damage and protect against electricity and physical harm. Next, change or repair damaged electrical cord. Damaged power cord can result in fire, electrocution, posing a serious domestic electrical safety risk. Every power cord and extension cord should be regularly checked for fraying and cracking and repairing or replaced as necessary. Lastly, we can turn off electricity to reduce the potential risk. To prevent the power surges, overheating, and phantom drain, which is the amount of energy an object needs even when not in use, unplugging useless equipment also protect it from this risk. Next, let's see the simple circuit with a fuse. Why fuse? Because the main purpose of the electric fuse is to protect electronic equipment against overcurrent, short circuit, and unbalanced loads. Small circuit breakers are electrical fuse main purpose. They are used as a safety measure for human in addition to protective equipment. In the conclusion, by centralizing and reducing the number of power converters, energy saving are possible. Small energy and cost saving in residential and commercial building may be achieved with this technique. To work and succeed, Any electrical apparatus or equipment need to have access to appropriate electrical engineering materials such as insulators, conductors, and magnetic substance. DC power supplies are frequently used to power motor in many industrial and commercial applications. An AC power supply is an electrical device that transforms alternating current, AC, from a wall socket or other source to a preset voltage and frequency. That's all, and thank you from Group 7s.